Welcome back, infrastructure admins. If you're gearing up for the Nutanix Certified Professional Multi-Cloud Infrastructure 7.5 certification, we've got an incredibly specific, highly testable objective to unpack today. We're zeroing in on Objective 6.2, which is all about virtual machine templates. We're going to use the official Nutanix documentation to build a complete mental map of this topic. We'll figure out the underlying mechanics together so you can walk into that exam room with absolute confidence. Let's get right into it.
Okay, let's dive into our roadmap for today. First, we'll look at why VM templates matter. Second, creation and customization methods. Third, common exam traps and edge cases. And fourth, the key facts you absolutely need to memorize. All right, Section 1. Why VM templates actually matter. Just to make sure we're all starting from the exact same baseline, let's quickly knock out a few core acronyms. A VM, or virtual machine, is just your standard software-based computer. AHV, the Acropolis hypervisor, is Nutanix's native hypervisor where all these VMs live and breathe. And Prism Central, or PC, is the multi-cluster management plane. Honestly, Prism Central is the absolute center of the universe for this specific exam objective. When you're scaling an environment out to hundreds, maybe thousands of VMs across entirely different physical locations, you desperately need a centralized control plane. Prism Central is that interface. It's exactly what we use to create, manage, and seamlessly deploy our templates across multiple AHV clusters all at once.
The official Prism Central guide frames this perfectly. It says, a VM template can be considered as a golden image or a master copy of a virtual machine. It captures the exact hardware configuration, the guest OS, and any pre-installed applications you might have. Relying on these golden images guarantees absolute consistency across your entire deployment, which completely eliminates configuration drift. So think about it. Instead of manually installing Windows Server and IIS on 50 different web servers one by one, a single golden image lets you spin up that entire fleet in minutes. You know for a fact that every single web server is configured identically right out of the gate.
Moving right along to Section 2, creation and customization methods.
So, when you create a VM template, you aren't just doing a raw, dumb copy of a disk, right? If you just clone a machine without properly prepping it, you're going to end up with a mess. Identical IP addresses, naming conflicts, duplicate Windows security identifiers, it's a nightmare. To prevent this, we customize the guest operating system so it generates unique identifiers the second it boots up. Now, the exam definitely expects you to clearly contrast the two primary guest OS customization pathways. For Windows environments, you're using Sysprep, which relies on an XML-based answer file like unattend.xml to handle those customizations. On the flip side, for Linux environments, you use Cloud-Init. Cloud-Init is this super powerful utility that runs super early in the boot process to configure the OS using something called user data. So lock this in your brain. Sysprep equals Windows and XML, while Cloud-Init equals Linux and user data.
Furthermore, when you're actually setting up these customizations in Prism Central, you have two methods to choose from. You can use a guided script, which is just a really simple, intuitive wizard interface right there in PC for setting basics like the username, password, or hostname. Or, if you have way more complex needs, you'd go with a custom script. Let's say you have a really intricate legacy bash script for a specialized Linux domain join, or some crazy package installation workflow. The custom script option lets you bring your own externally created Windows Sysprep or Linux Cloud-Init script right to the table. And here is where the magic happens. As long as Nutanix Guest Tools or NGT is installed, the moment that deployed VM powers on for the first time, it automatically executes those customizations. Literally, zero manual intervention required.
Now, what's really interesting about this next part is the architectural secret hiding just beneath the surface of a template. The documentation spells it out. The template data is saved as a VM recovery point and co-located with the source VM, meaning it's not some entirely new proprietary file type they invented. Under the hood, a template is actually just relying on standard Nutanix recovery point mechanics. It leverages the exact same underlying storage snapshot technology that you already use for backups and data protection. Let's definitely slow down the pacing right here, because if I were writing the exam, this is exactly what I would test you on. The system stores the template's metadata, the lightweight configuration details, up in Prism Central. But the actual heavy data, the physical storage of the recovery point itself, that stays co-located with the source VM down on its original cluster. So this brings up a massive question. How does a template cross cluster boundaries?
Well, if you deploy a VM from this template to an entirely different cluster, Prism Central steps in and seamlessly orchestrates the copying of that underlying recovery point over to the destination cluster in the background, right before the actual deployment even happens.
Of course, as your environment evolves, your templates have to evolve right alongside it. Let's say Patch Tuesday rolls around. You absolutely don't need to build a brand new template from scratch. Instead, you just update the existing configuration, patch the OS, and create a new VM template version. Prism Central is awesome because it maintains a historical record of all these versions for you. When it comes time to actually deploy a machine, you need to remember that by default, the active version of the template is the one that gets deployed. You can easily test a newer version first, and once you've validated it, simply select it in the UI to make it the new active version for everyone else to consume.
Let's do a really quick run-through of the exact step-by-step procedure for deploying a VM from a template just to burn that UI workflow into your memory. Step 1, in Prism Central, head over to Compute, then Templates. Step 2, select the checkbox next to your target VM template and hit Deploy VMs. Step 3, type in a unique name to identify the new VM. And Step 4, just pick your destination cluster from the drop-down menu. That's the whole shebang. It's incredibly streamlined.
All right, Section 3, Common Exam Traps and Edge Cases. This is where you really need to pay attention.
First up, let's rapidly define a few storage and disaster recovery acronyms, because they're totally central to the limitations we're about to look at. A VG is a volume group. RF is replication factor. PD is protection domain, and DR stands for disaster recovery.
So, according to the AHV Administration Guide, you flat out cannot create a VM template if certain conditions exist on your source VM. These are hard blockers. You're blocked if the VM isn't on AHV, or if it happens to be an agent or a Prism Central VM. You also can't create a template if the VM has disks sitting on containers with a replication factor of 1. Templates require standard fault tolerance to work, period. You're also blocked if the VM is protected by legacy PD-based disaster recovery. But here is the biggest exam trap of them all. You are completely blocked if any volume group is attached to the VM. Why? Because volume groups are typically shared, independent storage entities. They just aren't meant to be casually cloned and distributed through a basic VM snapshot model. If you spot any of these conditions in an exam scenario, just remember, template creation is going to fail.
Next, let's knock out 2 final acronyms before we cover what actually does not copy over during a deployment. NGT is Nutanix Guest Tools, and QoS is Quality of Service, which you'd use to throttle or guarantee specific disk performance metrics.
So, the crucial point here is, if a template is a golden image, does it literally copy every single thing during deployment? Actually, no, it doesn't. When you deploy a new VM from a template, it's not a 100% flawless clone of every metadata attribute. The docs explicitly tell us that VM templates do not copy host affinity attributes, the Nutanix Guest Tools installation state, or the quality of service configuration. And when you think about it, that makes perfect logical sense. Host affinity rules tie a machine to specific physical hardware nodes. That would make any sense if you're deploying to a completely new cluster. So you must remember to manually reconfigure those 3 specific attributes on your newly deployed VMs if you need them.
Okay, pause for a second. Here is perhaps the biggest architectural trap of all. What do you think happens if an admin, maybe doing some overly enthusiastic routine cleanup, accidentally deletes the underlying VM recovery point that the template relies on? Well, disaster strikes. There's no safety net. The template object itself does not protect that underlying recovery point from being deleted. So, if a user with the right permissions nukes that snapshot down on the cluster level, your VM template deployments are going to fail from that moment forward. The template object might look completely fine sitting up there in Prism Central, but the heavy data, it's gone.
Which brings us to our final section, Section 4, Key Facts to Memorize. And this brilliantly illustrates how neatly we can categorize all this. For Windows VMs, you're using Sysprep with an XML file. For Linux VMs, it's Cloud-Init with user data. Both of those can be configured right in Prism Central using either a custom script or the simpler guided script. And remember, when it's time to actually hit deploy, Prism Central automatically grabs the active template version by default. Let's stack these final 4 high-yield facts so you have them locked in for Objective 6.2. First, remember the architectural secret. Template data is literally just a co-located VM recovery point that orchestrates cross-cluster copies right before deployment. Second, the active version always rules the default deployments. Third, remember what gets left behind. Affinity rules, NGT installation states, and QoS configurations absolutely do not copy over. And finally, keep your eyes peeled for those creation blockers and troubleshooting questions, especially attached volume groups and RF1 containers.
So knowing exactly how that underlying recovery point dictates literally everything, from cross-cluster deployments to sudden mysterious deployment failures, gives you a massive advantage on Objective 6.2. But stepping back from the exam for a second, it brings up a really interesting question for your own environments. As we push further into this era of infrastructure as code and declarative deployments, are traditional VM templates eventually going to become obsolete, or will they just keep evolving to handle new demands? It's definitely something to chew on as you continue leveling up your infrastructure skills. Thanks so much for joining this explainer, and we'll see you in the next one.